Hello everybody, this is the demonstration phase of the example code head join offset. Previously, we have used a join offset to have either a special value of 0 or 1024. So you have a specific servo, you have 0 is join offset, and then all the goal position that you define in a motion page apply. If you somehow set up that specific actuator having a join offset of 1024, and then you can independently control that servo using a goal position command inside your code. And we've shown those two examples already. In this code, we'll show you a third way to use the join offset, which is its valid value. It can be between -255 and 255. And essentially, I'm trying to show you somehow you can get a motion from stillness, essentially. So let's see. First, what is the units of join offset? If you remember the goal position, we can give them legal value is between the 0 and 1023, 512 being the middle position at 150 degree here. Okay, so in a way, so if let's say your goal position is 512, minus 255 is over here, plus 255 is over here. Okay, so the join offset essentially added or subtracted from the current servo position. And why do I say stillness? Because in the program, part of the main endless loop is this piece of code is if I found out the robot is not moving, and then it's sent it to initial position. And then the initial position, servo 17, is set at position 512. So you can visualize this code when it's running at runtime. It found out if not moving, it's sent to initial position. The initial position is the ready position. So because of the main endless loop, you can see that they keep on sending the robot to maintain the initial position. That means outwardly, the robot stays still. You tell it to stay still. Okay? But how can you achieve motion then? So expanding the code out later is if I push R, it will subtract 1, but in the video that I'm going to show you next, I actually use a number of 10 so that it's moving more, so it can be shown easier on the demo. So if R is -1 from the current R join offset, if you push L, it will add 10 to the current join offset. And you can see that because I'm subtracting, there's a limit of -255 to be legal, right? So if somehow it goes more than -255, it will clamp it at -255. Same way, if it found out that computationally it gets more than 255, it's going to clamp out the 255. Okay? So that's the motion part, because the join offset is being changed every time you push R or you push L. And if you push 1, it resets the join offset to 0. Okay? So we'll see how that goes. So consequently, if you move these two together, is you set the join offset with the current join offset, which we know that we can modify if you do R, L, or 1. And once you set the join offset to a new value, and then when you apply the motion index initial position, even though it's already there, which is stillness, you're going to see you're going to get motion from stillness. So we're ready to go now. Let's see, the camera is in position. And let's see, the remote control should work disconnected, but it's gonna get started. Okay, here we go. So this one will show you the join offset. It's currently 0 now, and then where they are and how they're changing. Okay, so if I push right, you can see that the robot is turning its head to the right. Okay, and then that left is turn it back. So it's applying the join offset even though it keep on playing the initial position motion pace all the time. So this is what I mean by motion from stillness. If I push 1 now, it reset it to 0. That means the motion play, whatever setting in motion play is taking over command. So now, you see.